PragerU has a tenuous relationship with facts. That is to say, they don't really put many in their videos. So that means that any videos they do on climate change, like the ones I'm going to be watching in this video series, are basically just full of either misleading statistics, false claims, or outright lies backed up with no data. I don't want to spend a lot of time on this channel going back to old PragerU videos to debunk them, because I'd rather look more forward to climate solutions as opposed to looking back on past climate wrongs. So I'm making one big comprehensive video which will debunk all of PragerU's climate change videos, not all of their environmental videos because there's way too many of those, but all of the videos that directly relate to climate change or call it out in some way. And I'll be releasing the debunkings of each specific video as I do them, and then at the end I'll make one big video compilation with all of them. So with all of that said, let's get right into the first climate change video that I will be debunking. Climate Change, What's So Alarming with Bjorn Lomborg.
Carbon emissions are rising, and faster than most scientists predicted. But many climate change alarmists seem to claim that all climate change is worse than expected. This ignores that much of the data is actually more encouraging than expected. Yes, Arctic sea ice is melting faster than models expected, but models also predicted that Antarctic sea ice would decrease, yet Antarctic sea ice is increasing.
So we start off with statistics right away, which is nice, something easy to fact check, and it's something that is a relatively honest portrayal of the data as of Bjorn's time, because this video was released, I think, in 2017. Now, this is one of the better Prager videos, which means that some of the statistics they might present correctly, like this one. So let's see what the picture is now when it comes to Arctic and Antarctic sea ice as of 2020, not just 2017. From climate.gov, we can see that a recent downtrend in Antarctic sea ice has meant that the entire trend is basically flat. There was a slightly positive trend going into the mid-2010s, but that has since been flattened out by the new years being pretty small on Antarctic sea ice. And the article even says as much, saying, overall, the long-term trend in Antarctic sea ice is nearly flat. And this isn't an issue of Bjorn misrepresenting the data, because it was a slightly upward trend, but new information has updated that. Though, even with this flat trend, or before when it was slightly positive, we can see from other sources that even at the time, global sea ice was still shrinking. So losing some in the Arctic and gaining some in the Antarctic, it was still the case that overall sea ice was on the downward trend. Like this article mentions, the yearly average global sea ice coverage reaching its lowest value in 2017 with a slight rebound in 2018. And even looking just at Antarctica, there are still some worrying trends. Still, the frozen continent has become warmer and has lost billions of tons of ice as a result. Future responses to warming air and ocean could have worldwide consequences. This article talks about the areas that the Antarctica is losing sea ice, some areas it's gaining, some areas it's losing, and issues like the water around Antarctica becoming warmer, which will lead to future melting and possibly having Antarctica go into a downward trend like the Arctic, something we'd want to avoid. And all of this helps to just paint a more full picture of what Bjorn is talking about, as opposed to just saying, oh, Arctic sea ice is going down, but Antarctic is going up. Well, Antarctic is actually pretty flat, Arctic is still going down, global is still going down, sea temperatures are rising, and that will induce more warming as we go into the future.
Yes, sea levels are rising, but the rise is not accelerating. If anything, two recent papers, one by Chinese scientists published in January 2014 and the other by US scientists published in May 2013, have shown a small decline in the rate of sea level increase.
Now here we're getting into more contentious territory. Making a strong claim like the rise is not accelerating is going to need significant evidence to back it up, and two papers are a good start, though we're going to see that one of the papers doesn't really drive home the point that Bjorn is talking about, and more recent research has shown that the rise is accelerating. So I found the two papers that Bjorn is talking about. The first one, Global Sea Level Trend during 1993 to 2012, does state that the global mean sea level started decelerating since 2004, with this is the current rising rate as of 2012. So this paper is defending what Bjorn is saying. So that's solid. He has a paper supporting what he's talking about. That's fine. But the second paper, titled Recent Sea Level Trends and Accelerations, Comparison of Tide Gauge and Satellite Results, only looks at a host of tide gauges from the US, which, to be fair, I'm not an ocean scientist to any degree, but I would imagine you'd want a global set of data as opposed to specifically tide gauge data that is unique to only the US. And then there's even been some criticisms of this paper or of people using this paper in the way Bjorn is saying. And in my sources, you'll find a link to one of the articles talking about why this paper doesn't say necessarily what Bjorn is saying it does, and why using purely US data to create a global trend isn't the best way to do things. I also said that there's more recent research talking about sea level rise. Looking at NASA's website, they report on a study in 2018 showing that global sea level rise has been accelerating in recent decades, according to a new study based on 25 years of satellite data, which to my knowledge would be more robust than tide gauges, especially because it's a global set of data as opposed to just US data. And I'll even link to the study itself, Climate Change Driven Accelerated Sea Level Rise Detected in the Altimeter Era, which concludes with an estimation of climate change-driven acceleration of global mean sea level over the last 25 years to be 0.084 plus or minus 0.025 millimeters per year squared. So this is more recent data looking over a longer time period that supports the idea that sea level rise is accelerating. And even if sea level rise was decelerating, sea level rise is still something to be worried about. But it accelerating is something to be even more worried about, which seems to be the case from the data overall.
We're often being told that we're seeing more and more droughts, but a study published in March 2014 in the journal Nature actually shows a decrease in the world's surface that has been afflicted by droughts since 1982.
Again, Bjorn uses a real source that you can look up, and that is what I did. And we do see the graph that he presented being shown in the source. The issue I have with this is that this isn't a paper talking about drought over time or the difference in drought from the past to the future. It does deal with that in the paper, as we saw with the graph, but this is a paper that's defending a certain methodology of tracking droughts, the Global Integrated Drought Monitoring and Prediction System. It's basically arguing that this is a strong tool for covering droughts, and in the paper in discussion of this defense, they talk about droughts over time. So it isn't a robust look focused on droughts over time, but that's more a tangential note, which isn't necessarily to say it's wrong, but in terms of like having a source defend your claim, that's not necessarily the best way to do it. And if we want to look at some commentary talking directly about climate change, droughts, and drought change over time, we see a slightly different picture than what Bjorn is presenting. This is a paper titled Global Changes in Drought Conditions Under Different Levels of Warming, published in Geophysical Research Letters in 2018. And I just wanted to look at the introduction because it gives a kind of overview of the background going into talking about droughts in the future with climate change. It gives a recount of what the current situation is. While global long-term trends in drought frequency and severity remain an element of debate in the literature, in part owing to a lack of observations and a long list of sometimes conflicting drought definitions. So it's saying here that there's an issue with getting a clear picture on drought severity and frequency over time because there's not necessarily a lot of direct observations looking at that, and sometimes there are conflicting definitions. But it goes on to say, regional studies suggest an increasing trend in intensity and frequency of drought in several parts of the world, such as the Mediterranean, West Africa, and central China. In other regions, such as central North America and northwest Australia, drought conditions have become less severe in the second half of the 20th century. So, certain places have increased drought trends and certain places have decreased drought trends. It could even be that climate change overall doesn't increase total land area under drought, but it makes droughts more severe in certain areas, and it makes places that aren't used to having droughts get droughts, which would be more damaging than a place that's already prepared for droughts and is used to having them. So again, Bjorn doesn't really give the full picture when he's discussing it, which to be fair, it's a short video, so they're not going to be able to do everything, but it's a lot of little things that add up to paint a kind of deceptive picture of the overall state of climate change and climate change discussion. Because the thesis of the video is going to be, hey guys, climate change isn't something that we need to worry about as much as people are saying it is. And if you want to present that very strong thesis, which kind of goes against the grain of most scientists and scientific communities, you're going to need very strong, robust, clear evidence for that. And the kinds of sources and data that Bjorn is pulling is not that kind of strong data.
Facts like these are important because a one-sided focus on worst-case stories is a poor foundation for sound policies.
So far, what he's presented haven't been worst-case stories. Worst-case stories would be looking at like the possible worst-case predictions from climate change. For example, some of the stuff in the book The Uninhabitable Earth by David Wallace Wells is self-admittedly worst-case stories, worst-case scenarios. It's a really good book. I recommend you read it, but that would be more along the lines of what Bjorn is talking about. And that is a minority view. Most scientists get scared by books like that or more alarmist-based rhetoric because they don't want to scare people. Current mainstream climate discussion, for the most part, is not very alarmist. And I would argue, and I think a good amount of other people would argue, it should be more alarmist because it's a really alarming thing.
Hurricanes are likewise used as an example of things getting worse. But look at the US, where we have the best statistics. If we adjust for population and wealth, hurricane damage during the period of 1900 to 2013 actually decreased slightly.
So here it's kind of weird that Bjorn uses hurricane damage as opposed to total hurricanes. With increases in wealth and technology, we can be better prepared to prevent hurricane damage or prepare for hurricanes. That also means there can be more damage because hurricanes can damage more buildings because we have more expensive buildings and structures. So it kind of goes both ways, but this doesn't contribute much to the climate conversation because of these other kinds of factors really muddying this kind of statistic if we want to use it to glean specific information about climate change. So I see why Bjorn included it to try to help his case that, oh, these things are going down. But hurricane damage statistics don't really bring much clarity to this climate discussion, at least when they're not paired with any further analysis, which Bjorn doesn't provide.
At the UN Climate Conference in Lima, Peru, in December 2014, attendees were told that their country should cut carbon emissions to avoid future damage from storms like Typhoon Hagupit, which hit the Philippines during the conference, killing at least 21 people and forcing more than 1 million into shelters. Yet the trend for strong typhoons around the Philippines have actually declined since 1950, according to a study published in 2012 by the Journal of Climate.
Again, this is a study that you can look up, and I did. Surprisingly, the study adamantly disagrees with Bjorn about the statement he just made. If we look it up, it's a paper titled Historical, Global, Tropical, Cyclone, Landfalls. That is a lot of adjectives. And multiple times in this paper, the authors explicitly disagree with the statement that Bjorn made, that major typhoon frequency has gone down in the western North Pacific. Looking at their abstract and then later their conclusion, the analysis does not indicate significant long-period global or individual basin trends in the frequency or intensity of landfalling TCs, which are tropical cyclones, of minor or major hurricane strength. That's to say there aren't any significant long-term global trends or individual basin trends. The western North Pacific would be an individual basin, and the study is saying that there are no trends in the frequency or intensity of minor or major hurricanes, which is explicitly not what Bjorn said. He said there was a decrease, and this paper is saying no, there wasn't. There were no trends that we could see. We can see their data for the Northwestern Pacific Basin right here. There's no obvious trend that meets the eye, and the study's authors, which did the analysis on this data, conclude similarly. Within the resolution of the available data, our evidence does not support the presence of significant long-period global or individual basin linear trends for minor, major, or total hurricanes within the periods covered by the available quality data. So in the abstract and the conclusion, the authors make a point to note that there are no long-term trends that they can observe from the data, or statistically significant long-term trends, I should say. So Bjorn is just lying about what the paper says, and it's a small lie. He's saying it's going down a little bit in this one specific basin, but it's just not the case. And this kind of small little lies, small little misleads, which he uses a source that's talking about what he's talking about, looks at what he's looking at, but he just slightly tweaks it to make it more sympathetic and supportive of the claims he's making and the thesis he's trying to drive home. To me, this kind of thing erodes any credibility Bjorn might have, and kind of makes me question anything else he's saying that I can't necessarily fact check or haven't fact checked as being possibly not true in the same way that this is not true.
Again, we're told that all things are getting worse, but the facts don't support this.
That's kind of a funny statement, since even some of the facts Bjorn has presented don't support what he's saying.
This does not mean global warming is not real or a problem, but the one-sided story of alarmism makes us lose focus.
Again, he hasn't really presented examples of significant alarmism or debunked said examples. He showed us some misleading statistics about things getting better, but that's not much in the way of arguing against alarmism.
if we want to help the world's poor, who are the most threatened by natural disasters,
That's true.
it's less about cutting carbon emissions than it is about pulling them out of poverty.
It's actually very much about both. Obviously, pulling people out of poverty will give them better tools to deal with climate change and to live better lives, to be healthier, to be more prosperous. However, continuing carbon emissions is going to continue to change our climate in ways that the poor are going to be the least equipped to deal with.
If you're rich like Florida, a major hurricane might cause plenty of damage to expensive buildings, but it kills few people and causes only a temporary dent in economic output. If a similar hurricane hits a poorer country like the Philippines or Guatemala, it kills many more people and can devastate the economy.
Now, this is again something that paints a kind of reductive picture in favor of Bjorn's points, because we can look at examples like Puerto Rico after Hurricane Maria, and they lost $43 billion in damage. Quoting this news article about a government report, the economic sectors will keep feeling the impact for an undetermined amount of time. They don't even know how long this is going to negatively impact Puerto Rico. While Puerto Rico isn't a state, it is part of the US, and the US, with all of the money and riches we have, should be able to provide significant defense technology preparation for a hurricane in our territories. But $43 billion is basically half of Puerto Rico's GDP, which is a huge economic dent. So it's not as clean of a picture as what Bjorn is saying, since even in rich countries or rich areas, there are oftentimes going to be areas that are overlooked that can still get extremely damaged from natural disasters, especially if natural disasters get worse from climate change or simply get more variable and more unpredictable compared to what we're used to.
So let's be clear, climate change is not worse than we thought. That doesn't mean it's not a reality or not a problem. It is.
I'm glad that he agrees that it's a reality and a problem, but in many ways it is worse than we thought, and we'll get into that in a little later.
But the narrative that the world's climate is changing from bad to worse is unhelpful alarmism that prevent us from focusing on smart solutions.
So there are things to make us think that the climate is changing, not necessarily from bad, but the climate is changing and it's changing for the worse for people. Almost any change in the climate would probably entail hardships for humanity because we've had a relatively stable climate for all the time that we've had civilization. There hasn't been significant fluctuation in the temperature or carbon since civilization really dawned. But we've changed the amount of carbon in the air to the point that it's not anything close to what it was for the past 800,000 years. It has never reached the levels it's reached now in that time. There are periods of the Earth's history where it has reached the current levels, but it's not really relevant to humanity to talk about a time when there were crocodile-like beings at the North Pole.
A well-meaning environmentalist might argue that because climate change is a reality, why not ramp up the rhetoric and focus on the bad news to make sure the public understands its importance? But that's exactly what we've done for the past 20 years.
That is not what we've done for the past 20 years. Looking at a source from Scientific American, it goes over why climate science predictions have proven to be too conservative, and conservative just in the sense of downplaying things. For some examples, we can look at sea ice or sea level rise, which are two things we've talked about already. In the 2007 report, the IPCC concluded the Arctic would not lose its summer ice before 2070 at the earliest. But the ice pack has shrunk far faster than any scenario scientists felt policymakers should consider. Now researchers say the region could see ice-free summers within 20 years. Arctic sea ice is melting faster than scientists or alarmists said it would. Maybe you could find some alarmists that said it was going to be gone by 2002, but we're looking at the IPCC, which is kind of the global face for scientific consensus on climate change. Sea level rise is another. In its 2001 report, the IPCC predicted an annual sea level rise of less than 2 millimeters per year. But from 1993 through 2006, the oceans actually rose 3.3 millimeters per year, more than 50% above that projection. And we saw that in our sea level rise piece, it agreed that sea level rise was around 3 millimeters per year and accelerating by 0.084 millimeters per year, which is pretty scary, especially when scientists have been saying it's going to rise less than that. So to Bjorn's claim that we've been trying the alarmist route for the past 20 years, We haven't been trying the alarmist route. We've been trying the conservative route of downplaying.
Yet, despite dramatic headlines, apocalyptic documentaries, and annual climate summits,
So I will say there's a higher chance of climate alarmism appearing in some media or in some documentaries just because the media likes sensationalism and it sells. It sells magazines, it sells newspapers, it sells clicks. People like clickbait and hyping things up. So with climate change, you're going to get similar stuff. If we look at scientific releases and research claims, we don't see a picture of alarmism. And annual climate summits are really good because they help us figure out what we want to do about this climate change and what we want to do with the research, which is something that isn't inherently alarmist at all. If we have annual climate summits, making sure the climate is doing okay is a good thing to do, and having a summit every year isn't. And I can't imagine having a summit every year is a terribly alarmist thing.
carbon emissions continue to rise, especially in rapidly developing countries like India, China, and many African nations.
Yeah, the carbon emissions continue to rise, which is too bad. And especially in industrializing nations like China and India and countries in Africa, that's going to be a big thing. They want to industrialize as fast as they can, and carbon emitting fuels can be an easy way to do that.
Alarmism has encouraged the pursuit of a one-sided climate policy of trying to cut carbon emissions by subsidizing wind farms and solar panels. Yet,
So again, I don't really see how he can claim it's been alarmism, but the climate policy of subsidizing wind farms and solar panels is a really good thing because we want new technology to replace old technology. That's generally what subsidies are for. And also, at least in the US, subsidies for fossil fuels still outnumber subsidies for renewable energy like wind and solar 4-to-1 over their lifetime. So in terms of subsidies, we give out subsidies to energy a lot, and wind and solar are just playing catch up at this point.
today, according to the International Energy Agency, only about 0.4% of global energy consumption comes from solar photovoltaics and windmills. And even with exceptionally optimistic assumptions about future deployment of wind and solar, the International Energy Agency expects that these energy forms will provide a minuscule 2.2% of the world's energy by 2040.
So the International Energy Agency is a really good resource for this kind of thing. International energy statistics, projections, and all that. Though to my knowledge, they're not known for exceptionally optimistic assumptions. In their recent releases, they do have different scenarios where it's more of a business as usual scenario or a very active climate concerned scenario. However, a lot of their predictions are based on current policy in countries. So they're seeing what are countries currently saying that they're going to shoot for in the future, and what would that look like in terms of energy consumption. I wasn't able to find the specific data points that he presented, the 0.4% and the 2.2%. But again, it does present a kind of skewed picture of the role of solar and wind even now and where they're going to be in the future. If we look at current data from the IEA, we see solar and wind taking a very stronger, more influential role in the global energy market, and that's even on their business as usual assumptions, not to mention anything of the fact of their more optimistic assumptions. This is something I was able to find, how much of world energy consumption and production is from renewable energy. And this has total renewable energy, which includes hydropower. Currently, solar and wind are less than hydropower, though wind is getting pretty close to it. Renewable energy consumption at 15% in 2018. So renewables are 15%. That's a pretty good amount, especially when you take into consideration that the future of renewables is going to be largely solar and wind. If we look at their 2019 International Energy Outlook report by the IEA, the people Bjorn is citing, we see that renewable energy is set to become the leading source of primary energy consumption by 2050 in their basic reference case. So by 2040, it wouldn't be the number one, but it would be above natural gas and coal, and it would be pretty close to petroleum and other liquids. Bjorn might say, oh, but wind and solar are still going to be really small parts of that. Well, that's also not true according to IEA. Wind and solar dominate growth in renewables generation. These are the projections for the share of electricity generation from renewables. And we can see in 2010, it's primarily hydroelectric. Though 2020, we have significant more wind and solar, and it keeps rising so that wind and solar become the dominant sections of renewable energy by 2050. And even by 2040, they're still outpacing hydroelectric. Now, don't get me wrong, I like hydroelectric. And just to sum it up, by 2050, wind and solar account for over 70% of total renewables generation, which is quite a large amount, especially if renewables are becoming a much bigger player on the world stage. We can see from some other IEA statistics that the current share of renewables in global electricity generation reached about 27% in 2019. Again, this isn't global energy consumption, this is electricity production. So things like energy consumption could be cars which run on fossil fuels. But if we change most of our cars to electric and we amp up electricity production, then renewables can cover a lot more of the global energy consumption because we've moved some of that consumption into the electricity sector and we've changed the electricity sector to be a lot more renewable. The IEA reports on renewables for 2020, or basically any reports they have, are really cool and filled with a lot of cool information, so I highly recommend checking it out. And this is just from their renewables report. Renewables will overtake coal to become the largest source of electricity generation worldwide in 2025. So renewables, mainly hydroelectric, wind and solar, and especially wind and solar for the future, are going to be big players. And this is even the case on an economical perspective. The costs for wind and solar are plummeting dramatically, and that's leading to a lot of their new usage. This IEA report even talks about how investors are going to be really big on renewables, saying the share of renewables growth coming from purely market-based settings triples from less than 5% today to more than 15% through 2025. That's a tripling just into 2025. The economics for wind and solar are basically undeniable.
In other words, for at least the next 2 decades, solar and wind energy are simply expensive, feel-good measures that will have an imperceptible climate impact.
Bjorn used that one statistic to justify this huge claim, which it doesn't support this claim. It's not a strong enough single statistic. You need more analysis to defend something like this. And we've already seen, for example, that expensive is not the case. Investors are getting on board, and so are major oil and gas companies. I deleted that source too quickly, so let me get it back. Major oil and gas companies' investments in renewable electricity capacity are expected to increase tenfold in just 5 years, just to 2025. So renewables are going to be the face of electricity and energy going into the future. It's just a matter of when, how long it takes. And Bjorn might say it's going to take 20 years, but oil and gas companies' investments increasing by 10 times over 5 years kind of disagrees with that. It makes it seem like it's going to be happening a lot faster. And this is emphasized even more by the fact that these are the people with the highest stakes in not having renewable energy become a big thing because it's their direct competitor. Though if they incorporated that in their portfolio, then no, it's not their direct competition because it's part of what they own. So what Bjorn is saying is simply not true. He paints a picture where renewables will have not as large of an impact as current data says they will, and then uses that to say they will have an imperceptible climate impact when that's not true. Significant curbing of emissions through renewables and through changing industry practices is how we rein in climate change and prevent, say, 3 degrees of warming. The difference between 2 degrees and 3 degrees of warming is pretty significant and is something we'd want to choose the lesser on. For specifics of the difference in those kinds of rates, again, I really recommend The Uninhabitable Earth, the book, as a great look at the differences between warming scenarios.
Instead, we should focus on investing in research and development of green energy to lower its costs.
Yeah, we should, and that is what we're doing. And the costs have plummeted on the orders of like 90% in the past 10 years.
So everyone will want it, including China and India.
If we have major oil and gas companies increasing investments tenfold into renewable energy, it's kind of clear that basically everybody wants it, since they're the last group that's going to want it. India and China just want any energy they can get because they're trying to industrialize as fast as they can. So while yes, China is producing huge amounts of coal, they're also the world's leader in installing new renewable capacity. They need to do a lot more to bring their emissions down, and we should engage in international agreements and international pressure to achieve that end. But China and India are just trying to industrialize as fast as they can. And to be fair, India is doing a good amount of a better job. India produces less CO2 per capita and even less CO2 absolutely than the US does. Now, with the US lowering emissions, hopefully that will change and India will surpass them, but per capita, India would still be miles behind the US in terms of emissions. So using China and India as a scapegoat for our inaction doesn't really pan out. China is the world's largest emitter, and we need to incentivize them to emit less, but that doesn't mean we shouldn't try to drastically reduce our own emissions, especially when it's cost effective to, because wind and solar are so cheap.
We urgently need a more balanced climate conversation if we are to make sensible choices and pick the right climate policy that can actually help fix climate change.
If we had a more balanced climate discussion, everyone would be much more alarmed about it. Currently, the degree to which climate change is a problem is way underestimated by most people and most politicians talking about it. A balanced discussion would be much more in favor of the alarmism that Bjorn is relatively scared of.
I'm Bjorn Lomborg, president of the Copenhagen Consensus Center.
And that's the video. Overall, Bjorn does a good job of using real statistics and kind of abusing them to mislead the audience and present things falsely, though sometimes he does just outright lie about what the data is saying, which really hurts his overall credibility and takes away from some of the less misleading at face value claims he makes throughout the video. Overall, the misleading statistics and occasional outright lies just take away from Bjorn's argument and thesis, and he doesn't have good standing to say that we're too alarmed about climate change. The reality is that we're not alarmed enough.